right, today is what we've been working for. I kept telling you we're baby stepping, we're building a foundation, and here's where we're building a foundation, or what we're building a foundation for. So way back before we even started this chapter, we worked on a day of distribution and combining like terms, and you guys were good about combining like terms yesterday. You remembered that. And we also worked on distribution that day, and why is because of today. So today our equations are going to have parentheses in them. So the very first thing we have to do is we have to expand the expression using the distributive property. In other words, pushing that number and multiplying it through the parentheses so that we no longer have them. Then we will collect like terms. Then we're just to where we were yesterday. Step 1 and 2 are the additional points of today, the additional work from today. Otherwise, it's just like yesterday. We get everything on one side with the variable, everything else on the other, and then work about that +1 coefficient. So let's do a quick reminder of distributing here. When you have a number right next to that, or next to parentheses, means you're distributing. In this very first one, what number specifically am I distributing?
4.
Specifically, what type of 4?
Positive.
+4. And the fact that it's positive makes a difference. Okay? So I write 4 times, and I write 1x. If you want to write x, that's fine. What type of 4 did you tell me it was?
Positive.
So +4 times 6. Notice I put a plus sign here because it was a +4. 4 times 1x, 4x. 4 times 6.
24.
Positive or negative?
Positive.
Positive. Can I combine those two? Are they like terms?
No.
How do you know, Isaac?
Because the 24 does not have an x.
Very good. The 24 doesn't have an x and the 4 does. Okay, so what's different about the middle one? Why would I make you do another one of these? Taylor? It's a negative that we're distributing. Be cautious here. So we have -3 times 5y. Now write -3 times 7. -3 times 5y is -15y. -3 times 7, you should be on the front side of that taking notes with me. -3 times 7 is -21. So it's a -21. Again, can I combine like terms? No. One has a y, one does not. Try the last one on your own. What are you distributing? 5, a +5. I got -20y minus 5. Yes? Why would I have you do that one when you're like, we already distributed a positive number once? What's different about this one, Taylor? Yeah, inside the parenthesis was different signs. Okay, so just be aware that the inside number and the outside number make a difference. Good work. Okay, so let's put it to the test. Go to number 1. Draw your line down your equal sign. What number am I distributing? 15. So go a little bit over on the left-hand side so you have a little bit more space. And you have to show me this. 15 times 20. Was 15 positive or negative? So +15 times 1d equals 420. Now we multiply. 15 times 20. 300. 15 times 1d plus 15d equals 420. You have to show me your distribution step. Okay? What's my next step? Minus 300 from both sides. I drag down 15D equals 120. Then divide by 15. 1D equals 8. You know you can check your work on every single problem? How? Plug it in. Go back to the original and plug in 8 for D. So if I put 15 parentheses 20 plus 8, I'm really hoping that this multiplies out or combines to be 420. Order of operations, what should I do first? Add 20 and 8 to give me 28. 15 times 28 is, did somebody check actually, or did you just say it's 420? It is? Okay. So that checks because that's what we wanted it to equal. You know when this is really useful? When it comes to your test, right? A nice way to double check after you're done that you have this correct. Answer wisely. Who's your favorite math teacher? Good job. Cross off number 2. Oh! Right now it's me.
Miss Law.
Good answer. Good answer. At home, I would definitely answer your dad. All right. Got it. A. What is my first step? I got to distribute my -3. So write it down. -3 times +9. -3 times 1x equals 33. -3 times 9. -27. Don't work ahead of me. -3 times 1x. -3x equals 33. Next step, add 27. -3x equals 60. Then divide by -3. X equals -20. Don't lose your negatives. Don't lose your negatives. All right, try B on your own. Try B on your own. Right here, when you take 5 times -7, you get a -35. Only put -35 there. Don't put 2 signs next to each other. It gets very confusing. So you just want to put -35. A equals 12. Be cautious. Questions they asked this morning was all about the distributing. That's where they were thrown off. So be very cautious. Double check your multiplication. Okay? All right, top left. A little bit more intense once again. We're going to work only on the left side. First things first is we have to distribute. Is there distribution that needs to take place on the left-hand side? What number are you going to distribute? 6. Positive or -6? So 6 times 1x and 6 times -3. Ooh, do I take 6 times 10? Why not? Okay, what do I do with that 10? Just drag it straight down. Go plus 10. Stay on the left side. 6 times 1x. 6x. 6 times negative 3. And then same thing. Bring down the 10. What should my next step be on the left side? Don't do this. You are way not going to get this right. Don't try to skip steps, guys. You're not going to get this right. What is my next step? Nope. Micah? Very good. And I think that's what Taylor's going to say. Combine your like terms here, right? Negative 18 and a positive 10 are both numbers without variables. What is negative 18 plus 10? Okay, so on 6x, I'm going to drag down minus 8. Can I put 6x and a negative 8 together? Nope. 6 has an x. Negative 8 does not. All right, go up to the top right. What am I distributing? 2. 2 times 3x and a positive 2 times negative 4. 2 times 3x, 6x. 2 times negative 4, negative 8. Can I combine those? Okay, so drag it straight down so that ours are equal. Or on the same level, I should say. All right, our next goal is to get all our variables on one side. How do I get all my variables on one side? Say it again. Add or subtract? Subtract 6x from both sides. Now listen closely to me. 6x minus 6x, 6 apples, and you ate 6 apples. What's left? Nothing. They cancel. What is remaining on the left-hand side? Negative 8. On the right, 6x minus 6x cancels. What do you drag down? Negative 8. Here's a new situation for today. There are times that your variable's going to cancel. You have done this spot on correct. And here's what I have to tell you. You have to move your variable first or you're going to make a mistake. I'm promising you. 8 years of teaching this, and the people that are making mistakes are the ones that don't move the variable first. Does negative 8 equal negative 8? Are those the same number? Yes. The answer to this problem is infinite solutions. Infinite solutions, which means there are an unlimited number of answers. Any number you pick, if you plugged it in for x on the left and you plugged it in for x on the right, every single time you would get the same number. Whether it's 3/2, -5, 972, whatever number it is, it's going to work. The only time you get to write this, though, is the variable must cancel. That is the only time you even consider infinite solutions. And then you have a true statement. In other words, the two numbers are the same. 5 equals 5. 12 equals 12. -7 equals -7. If that's the case, then you get to say to me, yep, infinite solutions. All right, let's look at number 4. Stay on the left side. Do you need to distribute? What are you going to distribute? 8. 8 times 4. 8 times -2x. 8 times 4. 32. 8 times -2x. -16x. Can you combine those? No. So we go to the right side. Do I need to distribute? What am I distributing? 4. 4 times +3. 4 times negative 5x. Do I take 4 times 4x? What do I do with that? Just drag it straight down. 4 times 3? Whoa, 12. 4 times negative 5x. So minus 20x and plus 4x. Anything I can combine on that side? Okay, so negative 20 plus 4. Negative 16x. And I'm going to drag down the other side so that we are on the same level. I need to get all my variables on one side of the equation. How am I going to do that? Add what? Add 16x. Add 16x. Negative 16x plus 16x. Cancels. On the left, what is remaining? 32. On the right, negative 16x plus 16x. Cancels. What do you have left? 12. Now, did your variables cancel? Yeah, the variables absolutely canceled. Do you have a true statement? No. So here we have a false statement. So we have the opposite of what we had on the left. On the left, we said infinite solutions. Absolutely any number you plug in is going to make true statements. So guess what this answer is? No solution. There is not a single number that you can have that will plug in and make the left side equal the right side. I'm going to warn you, everybody gets no solution and infinite solutions happy, and they start writing that on every problem. That only happens if your variable cancels. All the problems on the front, they still had a variable. D was 8, X was negative 20, A was 12. Those have an answer. So don't just automatically assume your variables are going to cancel and you get to write one of those. On your own, do D. We're going to check in just a minute. Everybody go through and work through D. Bless you. I want to talk about one thing before you get too far. On the right-hand side, this question came up on your homework yesterday. Lots of people said, Ms. Hoff, I have that 10x and that negative 4x. And I think they're supposed to go together, but they're not right next to each other. As long as they're on the same side, we can absolutely put them together. So then usually the follow-up question is, well, do I add them or subtract them? I said, always do just what it says. 10 minus 4 is 6x. I got it all the way down to 10 equals negative 20. Is that what you got? So what is my answer to this? No solution. No solution. So many times people write 6x minus 6x and then they cancel and put an x down. If you put an x down, what number's in front of that? A 1. So you're telling me 6 minus 6 is 1? No. So 6x minus 6x, they cancel out. I mean, technically you could put 0x, but then it's 0, right? So we don't really need to put that. But I'm going to warn you, don't automatically assume every problem is no solution or infinite solutions. All right, one more. Everybody, deep breath. Exhale. It's a problem with words. You can do it. I believe in you. I'm going to help you get there. Mr. Richards' class is holding a canned food drive for charity. Juliet collected 10 more cans than Rosanna. Santiago collected twice as many cans as Juliet. If they collected 130 cans altogether, how many cans did Juliet collect? Remember the hamburger cheeseburger problem? The same thing. Remember when Ms. Hoff said we need to practice this because it's going to be on your test? Here we go. Here's the sentence I want to talk about most specifically. If they collected 130 cans altogether, that little phrase gives me that shorthand equation with words. What is the first thing I should write down if I tell you they collected 130 cans altogether? Equals 130. Aspen, what do you want to put on the other side?
Juliet's cans plus Rosanna's cans equals.
Careful. And don't forget Santiago. There's a third person in this one. Okay? But absolutely, meaning all of them added together equal 130. Because all three of these names are here, all three of those names need to go on the left-hand side. Because we need to figure out how we're going to represent Juliet, how we're going to represent Rosanna, and how we're going to represent Santiago. So we look. Juliet collected 10 more than Rosanna. If we want to figure out Juliet, who do I have to know? Rosanna. Do you know Rosanna? Okay. Santiago collected twice as many cans as Juliet. To figure out Santiago, I have to know Juliet. But you guys just told me to know Juliet, I have to know Rosanna. So who does everybody depend upon? Rosanna. Rosanna is the X. Juliet collected 10 more cans than Rosanna. X plus 10 for Juliet. Santiago collected twice as many cans as Juliet. What does twice mean? Times 2. But I have to take all of Juliet times 2. So we have to go 2 parenthesis X plus 10. We have to take all of Juliet's. We don't know what it is. It's X plus 10 times 2. Now, let's go fill in our equation. What am I putting in for Juliet? X plus 10 plus Rosanna. X plus Santiago. 2 parenthesis X plus 10 equals 130. Good work so far. What do you think my first step is now? Not add like terms yet. We got to get rid of those parentheses first. What number am I going to distribute? A 2. So drag everything else down. X plus 10 plus X. And then I'm going to take 2 times X and 2 times 10 equals 130. Now let's actually multiply here. Whoopsies. X plus 10 plus X plus 2X plus 20. Now I always put 1s in front of my X's here just to help myself out. Now I need to combine my like terms. A 1x, a 1x, and a 2x. 4x, and then a 10 and a 20. 30. Then minus 30. 4x equals 100. And last but not least, divide by 4. X equals 25. Now, don't circle that. In our problem, what did X stand for? Rosanna. Go back. What did they ask us? How many cans did Juliet collect? So we have to go back that we wrote Juliet over here was X plus 10. So Juliet collected 35 cans. Juliet collected 35 cans. Some of you have hooked onto this and you're like, I got these problems, it's no big deal. And some of you are like, I still am not understanding. That's where we got to ask for help. Okay, please, I'm telling you it's on your test. I'm telling you it's on your test. Start preparing for it. Okay. Who's your favorite math teacher? Miss Hoff. Cross off number 3. Cross off number 9. And number 11, I have a typo. 11, this should not say 47.50. It should say $7.50. The 4 should really be a dollar sign. I forgot to hold the shift key. I'm going to warn you again. Not every problem is no solution or infinite solutions. If you go back and start on number 1, I'll keep a pulse on what everybody's doing, and I'll give you the answers as everybody's getting them done, okay? All right, you have 9 problems for homework. You got this.